Hi, in this video, we're going to take a look at something called the neighbor cache. So the neighbor cache is similar to an ARP table in IPv4. A device that has an IPv6 address and an Ethernet NIC card needs to be able to map destination IPv6 addresses to an Ethernet MAC address. And like an ARP table, it has something called a neighbor cache. So the neighbor cache actually has 5 states. 2 that are noticeable, reachable and stale, and 3 that are transitory, incomplete, delay, and probe. In ARP, it's one or the other. It's either in there or it isn't. That's all ARP is, an ARP table. A neighbor cache gives us a little bit more information about the state of the MAC address and its associated IPv6 address. So just like an ARP table, the neighbor cache is the entries in the neighbor cache are added when the device knows an IPv6 address but not a MAC address. So we'll send out a neighbor solicitation message. The device that has that IPv6 address will reply with a neighbor advertisement message, and that MAC address of, in this case, PC1, that's contained in the neighbor advertisement will get added to the neighbor cache. Okay, so neighbor cache. Let's take a look at what it looks like. First, I'm going to do clear IPv6 neighbors. This is the neighbor cache on router R1. Then I'll do show IPv6 neighbors to show the neighbor cache. And as you can see, it's empty, IPv6 and no link layer addresses. I will go ahead and ping one of the PCs on the link. Okay. I send the echo requests, get the echo replies. Now when I do show IPv6 neighbors, my neighbor cache will show the IPv6 address of the device that I was trying to reach and its MAC address. And the state is reachable. We'll talk more about that in a moment. And the interface it uses to send the Ethernet frames out this interface here to reach that device. Okay, so a neighbor cache. If I waited 30 seconds later and I did that same command, show IPv6 neighbors, I'd see a slight difference. The IPv6 and MAC address is still in the cache, but the state has changed from reachable to stale. And if I ping it again, you'll notice that the neighbor cache has changed this time from stale to reachable. So what's with this stale state? What's happening there? Let's take a look. So here's an example of the neighbor cache on router R1. There's actually a process that the neighbor cache goes through known as the finite state machine. If there's no entry, meaning no IPv6 address and associated MAC address, no entry exists. How do we get an entry into the neighbor cache field? Well, that happens when a neighbor solicitation message is sent. And as soon as the device sends the neighbor solicitation message, we would see the IPv6 address in the table, but the state would be incomplete. Okay. Normally you won't see this because it happens really quick. Okay. The device will try and send for every neighbor solicitation message up to 3 neighbor solicitations messages sent. If 3 are sent and no neighbor advertisement returned, then the IPv6 address has no MAC address because it doesn't know the MAC address. But the incomplete state would be removed from the neighbor cache and no entry would exist. But what if the device sends the neighbor solicitation message and it receives a neighbor advertisement message? Okay. So if there's no neighbor advertisement message received, after a few milliseconds, it will send another one and another one. But let's say it does return a neighbor advertisement message. Then the IPv6 address, along with the MAC address in the neighbor advertisement message, would go into the neighbor cache, and it would be, the state would be reachable, and it stays in that state for 30 seconds. Okay. There's something called an unsolicited neighbor advertisement, but you can read about that in the book if you wish. But it stays in there for 30 seconds. Okay. At that point, it goes from reachable to stale. Now, stale isn't anything bad. It just says, look, I haven't heard from this device in 30 seconds, but I do have a mapping from its IPv6 address to its and IPv6 to MAC address. So it stays in the stale state. Okay. Let's say the device sends a packet. Okay. It had reached this device previously. It's in the neighbor cache, but it's stale. Okay. Say we send another ping, for example. Okay. The state will change from stale to delay, meaning resolution pending. If a packet is returned, like we sent the second ping, after it went from we were at reachable. Let's do this. It was incomplete. We sent a ping, right? Then it went from incomplete, well, it wasn't in the table, to we saw it was to reachable. And remember, we waited, that's a ping there. Then we waited 30 seconds, and it went from reachable to stale. Okay. Then we sent another ping. Okay, and that's where we are here. We sent another ping, and because it was in stale state, but we received an echo reply back from the device, it went from stale quickly to delay and then back to reachable. Okay. But let's say that it was stale, packet was sent, but guess what? We never heard back from the device. Maybe somebody went off link, maybe it got unplugged, somebody powered off, they took their laptop, we were trying to ping somebody's laptop. It was there, back in the time when it was reachable, but now we're trying to reach it again, it's no longer there. So after 5 seconds, if we don't get a packet back, say we're trying to ping it again, we wait 5 seconds, it says, you know what, I haven't heard from this device in 5 seconds. I better do re-resolution. I better send another neighbor solicitation message. So it will automatically send a neighbor solicitation message, say, hey, are you out there? If the device says, yeah, I'm here, sorry, I was just busy, I never returned a packet to you. But yeah, it returns a neighbor advertisement message, then we'll go back to reachable. But what happens if it never receives a neighbor advertisement message? Okay, it will, again, just like it did up here, send 3 neighbor solicitation messages. If no neighbor advertisement message is sent, it says, well, look, I tried sending you another packet. I did hear from you at one time. Went from reachable to stale because we haven't talked. I sent you another packet. I waited 5 seconds, never heard back from you. I sent the neighbor solicitation message. Matter of fact, I sent 3 of them. I never got a neighbor advertisement message back. So I'm guessing you are no longer around anymore, and I'll remove you from my neighbor cache. And you can see this entire process with debug IPv6 ND. Matter of fact, we'll do that. So I'm going to clear the IPv6 neighbor table, show that there's nothing in the table. Let's do a debug IPv6 ND and see the process of what happens when I ping this device. Okay. So let's see, it starts off with no entry exists, and I'm going to ping that address, and we can actually see it going all the way from, all the way to reachable. All right, so resolution request. Okay, so it goes from delete, which is no entry exists, to incomplete. Yeah, so it's sending a neighbor solicitation message, matter of fact, and then it says, okay, queued for resolution. So this is from the perspective of the router. Say, okay, I'm waiting for it to get resolved here. It receives a neighbor advertisement message. Right? says, great, I received the neighbor advertisement message. I've learned that this is its MAC address. I'm going to put that in my neighbor cache. Okay, so now it's gone from incomplete to reachable. Okay, and then those pings are sent. Okay, I do show IPv6 neighbors, and there's the IPv6 address and MAC address, and the state is reachable. Okay, so we can see the state from here to here. Neighbor solicitation message is sent. So it was sent, went into incomplete state, received the neighbor advertisement message. That's the device saying, yeah, you're looking for my IPv6 address. Here's my MAC address. So it says, great, I've got your MAC address now. I'm going to put it in my table. And I'm changing you from incomplete to now reachable. Yeah. Now, if we wait 30 seconds, remember what happens? We're at reachable. What happens after 30 seconds? We can see with debug IPv6 ND that the state changes from reachable to stale. Matter of fact, I do show IPv6 neighbors, and I can see that the state is now stale. Okay, so displaying the neighbor cache, we can display it. We've seen how to do it on a router, right? Let me make sure that we remember how to display it on Cisco iOS. Oh, come on, go back. There we go. Show IPv6 neighbors. That shows the neighbor cache on Cisco iOS. If we want to see the neighbor cache on a Windows host, NetSH interface IPv6 show neighbors. To display it on a Linux host, I do IP /6 neighbor show. And display it on my Mac, I use the NDP /A, kind of like ARP -A. So that makes that easy. Okay, to show you what happens after a certain amount of time, let's say we've shut down the WinPC that we're trying to ping. So let's see what happens. Okay, the state is stale, okay, because we did reach it previously. So we can see the state, that's where we're at right now, stale. Okay, so let's see what happens when we try and ping this device again, but hey, it's offline, okay? So what we should do is be seeing the process here, delay, probe, and then it goes back to delete. Let's see what happens here. Okay, so I'm going to ping the device again, and notice that I never was able to connect, never able to reach the WinPC, this IPv6 address, because it's been shut down or taken off the network. Okay, but we can see this with the show IPv6 and debug IPv6 ND. We see that when we did the ping, that the state went from stale to delay. Then it says, I sent the packet, right? So it's from stale to delay. I sent the pings, but I haven't heard anything back. Okay, so after 5 seconds, okay, I'm going to go to probe. Okay, so it says, that means I'm going to have to send a neighbor solicitation message. Okay, so I'm going to send a neighbor solicitation message. The question is it going to hear back? If it received a neighbor advertisement message back from the host, but the host is down, is disconnected. If it did receive a neighbor advertisement back, then we'd go to reachable. But we're not getting that neighbor advertisement message because we've shut down the host. So it sends second one, sends a third one. Okay. So the probe is deleted. It says I'm no longer in probe state and I'm going to delete state. Okay. So and it says I'm removing this entry from my neighbor discovery cache. Okay. Don't forget to do that undebug all. Okay, I do show IPv6 neighbors and it's no longer in there. So I went from stale to no longer in our neighbor cache. Okay. All right, so that's the neighbor cache. Kind of cool. Hope that helped let you understand the difference between the neighbor cache and a simple ARP cache for IPv4.